In example 6, we have a 28-foot slide at a water park. So there is the slide that makes a 60-degree angle with the ground. So we have a 60-degree angle made with the ground as it descends into a pool. We are being asked to find the vertical distance from the top of the slide down to the ground. So I'll call that vertical distance X we are looking for. Relative to the 60 degrees we have in this triangle, we want to find the opposite side, and we have the hypotenuse side. So in terms of right triangle trigonometry, I'm going to use sine because we want the opposite and we have the hypotenuse. So I'm going to write the equation that sine of 60 degrees is equal to opposite over hypotenuse. The opposite side is x and the hypotenuse is 28. We're trying to solve for x, so I'm going to multiply both sides of this equation by 28. So this will cancel, and I get that x is equal to 28 multiplied by sine of 60 degrees. Now I'm going to go to my calculator and make sure that I am in degree mode and do 28 sine 60, and that leaves me with approximately 24.25, and this is measured in feet. In example 7, we have an observer on the roof of a 40-foot building. So I'm going to go ahead and start drawing a roof, or a building rather. I know this building is 40 feet tall. So there's someone up here, and they measure an angle of depression from the roof to a park bench on the ground. So let's say that the park bench on the ground is right here. So they are measuring an angle of depression. I'm going to go ahead and draw in this line from there to the bench. The thing with an angle of depression is that you need to sketch a horizontal. So what do I mean by that? From the observer, the person on the roof, I need to sketch in this horizontal line. In between the horizontal line and his line of sight is where the angle of depression is. So a very common mistake I'll see is people will start their sketch off drawing that park bench and then stick the 24 degrees down there, which is incorrect. Angle of depression means you need to put in a horizontal. The 24 degrees is right here, which then we could use that and the fact that this forms a right angle to determine that this angle here is 66 degrees. And I got that by doing 90 degrees minus 24 degrees. Okay, so we are being asked to find what is the distance from the base of the building to the bench. So we are looking for this distance here. I'd like to mention that you could have also, maybe if you recall from geometry, that then this angle has to be 24 degrees. So it doesn't really matter whether you use the 24 degrees or the 66 degrees in the triangle. But what is important is that you realize that this angle here is not the 24 degrees. Okay. So I'll work with the 66 degrees. We're looking for, relative to the 66, we're looking for the opposite. And we have the adjacent relative to the 66. So if I'm using the 66 degrees, I would use the tangent function because SOHCAHTOA tells me that tangent of 66 degrees is equal to opposite over adjacent. And then I would multiply both sides of this equation by 40 to get that x is equal to 40 tan 66 degrees. And that comes out to be approximately 89.84 feet. I'd like to point out that even if you worked with the 24 degrees, as long as you had it placed correctly at that bottom side, then you would have been looking for the adjacent side relative to the 24 degrees, and you would have had the opposite side. So we still would have used tangent. It's just that we would have had tangent of 24 degrees equals opposite, which is 40, over adjacent, which would have been x. Now to solve this equation, I will get rid of the x in the denominator, and now I will have to divide both sides of this equation by tangent of 24 degrees in order to get x by itself. And again, I'm left with 89.84 feet.